Hello guys, welcome back. In our last session, we have discussed about HSRP and we have discussed about First Hop Redundancy Protocols. So what is the use of First Hop Redundancy Protocols and how many types of protocols are there in First Hop Redundancy Protocols, right? And also we have discussed what is the need of HSRP protocol. So in today's session, I am going to explain about how to configure HSRP and I will show you practically how it works. First of all, we need to understand without HSRP, what is the problem? Okay, just here, uh, imagine here, okay? This is my head office. This is my branch office. Between the head office and the branch office, I am using EIGRP protocol as routing protocol. You can use any one protocol, RIP, EIGRP, YSP, that is not matter. Just to routing purpose, I am using EIGRP. And in LAN side, I have one gateway. This is a router, okay? This is R1. This is R1 and this is R2. Just imagine, okay, this is not there. Right now it is not there. Just okay, like assume like that. I have only one router. This is the head. This is the branch office. In the branch office, I have one server, 192.168.1. 4.2 server. For example, this is the web server. This is the web server, abc.com. Now, this head office users can access this web server via this gateway. 192.1.1.2, right? So because in systems also we configure like this, right? 192.168.1.4 and the mask is 255.255.255.0 and the gateway is 192.168.1. So system, if the system wants to reach any other network, the system will go via 192.1.1. Means this router. Okay, as long as it is in operational mode, operational status, there is no any issue. This user can go successfully. Once this gateway is failed, this PC lost connectivity with the server. This PC cannot go, right? This is the problem. If you have only one gateway, if that gateway is failed, users in the LAN cannot go outside, right? This is the problem. Okay, right? To solve this problem, I will connect, generally we will connect one more router in the same network, right? So this is the another router. This is my second router. And here we will use IP 192.168.1.3. So now I have two routers in the LAN. We can use these two routers as gateway but at a time not possible. At a time we cannot use more than one IP as gateway. You can use only one IP as gateway in the systems. For example, okay, if you use 192.1.1.2 as gateway here in the system, 192.168.1.2, this PC will go via this way. Once this gateway is failed, this PC cannot go via this way automatically. Because again we need to change gateway 1.3. Then it will go, right? But we cannot change, right? In the production, because in the production we have hundreds of systems are there. It is possible when the primary gateway is failed to reconfigure gateway in all the system. It is not possible. It is impossible, right? This is also problem, right? Even if you have two routers, we cannot use these two routers as a gateway in the system. But how to solve this problem? To solve this problem, Cisco has developed protocol, hard standby redundancy protocol. This hard standby redundancy protocol provides the solutions to gateway failures. So this HSRP protocol provides default gateway redundancy, right? So this is the need of HSRP protocol. Now first we will configure these all routers, basic configuration, interface configurations, and routing protocol EIGRP. Okay, right? So, and I will test the this gateway failover. Okay, so I already prepared configuration. So in the notepad file, I will share this file. I will share this file in description section. So this is R1, enable configure terminal, host name, interface F0 by 0, and description. Uh, IP address 192.168.1.2 and mask and no shutdown. And another one, interface F0 by 1, IP address, mask, no shutdown. And this is protocol, EIGRP protocol. In EIGRP, I advertised 12.000 and 192.168.1.0. Copy this configuration, paste in R1 without HSRP. Okay, just only I am configuring just interface configuration and routing protocol. And in R2, these are interface configurations, interface F0 by 0, IP address and mask, no shutdown. Interface F0 by 1, IP address and mask and EIGRP. Copy this configuration, paste in router 2. Next, R3. In R3, we have three interfaces, F0 by 0, F0 by 1, F1 by 0. Here, okay, copy. And in R2, I have configured wrong. 1 second. Yeah, see here, rotary EIGRP, it is 192.1.0 only, not a 2.0. Okay. The first verify the EIGRP between the head office and the branch office routers. So because the routing is very, very important, right? If you don't have a routing properly, even though if you configure everything perfectly, users cannot access it. So that's why routing is very, very important. First, verify the routing here between head office routers and branch office routers. So click on branch office router. First, verify EIGRP neighbors. Show IP EIGRP neighbors. Yes, we have a neighbors, right? 12.001 and 13.001. And check the routing table. See, it has received 192.168.1.0 from both routers, 12.0001 and 13.001. 12.001 is this IP, 13.001 is this IP. So this router has received this LAN subnet from this way, right? And same way, primary router, this router should receive this network, branch office network, 192.168.4.0 network. Verify that. To show IP route 192.168.4.0 received from 12.002. And second router, second gateway, show IP route. See, it has also route for 192.168.4.0, right? Okay, no routing point of everything is good. So now first I will show you without HSRP. I have two routers, I have two gateways. So I will use this gateway 192.1.1.2 in systems. Okay, so go to system. Here in IP configuration, IP address is 192.168.1.4 and mask and gateway is 192.168.1.2. Okay, now test the connectivity. ping 192.168.4.2. It's pinging, right? So now check the path, how this packet is going. Traced 192.168.4.2. Okay, so command is what? TRACERT 192.168.4.2. See, this packet is going via 192.168.1. If 192.168.1.2 is failed, see, I will shut down that interface in here, interface F0 by 0 and shut down. I shut down this interface. Now check the connectivity. Ping 192.168.4.2. This PC cannot go because 192.168.1.2 is failed. Right? See, already we have one more gateway, but this PC cannot use that gateway automatically. Automatic failover not happens here without HSRP protocol. Systems cannot change its gateway to another IP address. So right now we need to configure HSRP. Understand? So again I will make it up interface. Interface F0 by 0 is upright. Now configure HSRP. HSRP is very easy. Only 3 commands are there. And this is the command. Okay, HSRP configuration is interface level configuration. Remember this point. It is not a configuration mode configuration. Okay, it is not a global mode configuration. So it is interface level configuration. Interface F0 by 0. Standby. The standby is the command. This command purpose is to enable HSRP protocol. This command enables HSRP protocol and group number. This is the number, right? This is the group number. These group number should be same both routers. This group number range is 0 to 255 if we are using version 1. If we are using version 2, the group number range is up to 4096. Okay, and virtual IP, this is the virtual IP 192.168.1.1. This is virtual IP. This virtual IP should be from same network. What is our LAN network? Our LAN network is 192.168.1.0, right? So yeah, the virtual IP also should be from same network. You can use any IP address from 1.1 to 1.254. But this virtual IP address should be configured same virtual IP on both gateways. And the priority 140. Okay, so here in the R1 priority 150 means this is the primary gateway. Okay, virtual IP priority is 150. You can use any value. The priority range is 0 to 255. Remember this point. Keep it in your mind. The priority range is 0 to 255, and you can use any number. Okay, but the default priority is 100. If you don't give this command, no problem. It will take default priority. And preempt is very important. So what happens if you don't give this preempt option? What happens if you don't give this preempt command? What happens? See here, for example, right now this is my primary gateway. Right now this is my primary gateway. If this gateway is failed after 10 seconds, what happens? So this secondary gateway will become active gateway. After some time, again if primary gateway comes to online, no use. So this primary gateway remains in the standby state only. If preemption is disabled. If we enable preemption, what happens? When this primary gateway again comes to online, it will become active gateway. Right? So this is very important. Preemption is very important in HSRP. By default, it is disabled. We should enable this. Okay. And these are the only 3 commands for HSRP. Same configuration in R2 also, but just only change priority value. So copy these 3 commands. Next. So here right now R1 become the active gateway, R2 become the, oh sorry, I configure wrong thing. Sorry. It is R2, right? So in R2 the priority is should be 140. So now here we got notification. This router become the standby, and R1, click on R1 here. How to verify whether it is active or backup? Command is show standby. Show standby. See here, group number 1, and what is the state? State is active. And virtual IP and virtual MAC address. These two are very, very important. Virtual IP. Virtual IP we configured 192.168.1.1, but virtual MAC address we did not configure, right? But by default there is one virtual MAC address. HSRP creates one virtual MAC address to provide default gateway redundancy. Without virtual MAC address, HSRP cannot provide default gateway redundancy. Remember this point, very, very important. How HSRP provides default gateway redundancy? By creating virtual IP and virtual MAC address. What is the virtual MAC address? Virtual MAC address is 0.0000.0C07 and AC01. Up to AC, this is the default one. 01 is our group number. We have configured group number 1, right? See here, group number 1. This is the group number 1. And what is the default version? Version 1 is the default version. And see, timers. Hello time 3 seconds and hold time is 10 seconds. And active router is local. This is the active router. And preemption is also enabled here. What is my backup router? 192.168.1.3 is my backup router. And what is the priority? 150. And if you want to see same information briefly, command is show standby brief. Interface F0/0, group number, priority, and state is active. Here see it's showing everything: virtual IP, standby IP, and active router. Now we will test connectivity. Okay, so click on PC and now send the ping packet. Okay, ping 192.168.1. See, it's pinging right. Now check the path. So how it's going? Trace at 192.168.4.2. Okay. See, packet is going via 1.2. If 1.2 is failed, okay, I will make manually shutdown. Okay, I will make it shutdown manually. Interface F0/0 shutdown. Right. And now test the connectivity again. Use up arrow here, up arrow on the keyboard. You will see previous commands. No need to enter a command again. It's like this: ping 192.168.4.2. No need to enter again this command. Just use up arrow in the keyboard. Okay, you will see previous commands. Oh, it's not going. Why? We have configured everything properly, right? Why it's not going? So we need to start troubleshooting. So first we will check the trace. Okay, so whether traffic is going or not. In the ping command, we cannot see how packets are going. Okay, remember this point. Ping provides only whether we have connectivity or not. That's it. Ping does not provide information about path. So to check the path, we always use trace. Trace at 192.168.4. Remember the difference between ping and trace at. Oh, this piece is not going. Why? Okay. We forgot to configure virtual IP as a gateway in the system, right? See, go to PC. Still PC uses 192.1.1.2, I think, right? See here. Yeah. Here we need to configure gateway virtual IP. Okay, remember this point. Yeah. Now test the connectivity. Now primary gateway is down, right now. So see here how it's going. Ping 192.1.1.4. is going right, and trace TRACERT. Oh, it's going right 1.3. And again, if primary gateway comes to online, no shutdown. Now see, it will go via primary gateway. It's going right. So if you want to check the path, command is tracer. See, it's going, still it is going via 103, right? Just wait for some time, because still you see this link is down still in switch side. Yeah, now check the connectivity, okay? Now trace ping is working, and trace, see, now it's going 192.1 instead of 1.2. It's a primary gateway, right? Correct. And again, I will shut down this interface in the primary gateway F0 by 0. Shut, okay? And now see here, ping, right? It's going. And how it's going? Trace it. It's going via 192.1 instead of 1.3. This is HSRP purpose, okay? And again, I will make it up, no shutdown, okay? Right. HSRP is working fine, right? So here we need to important virtual IP and virtual MAC address and priority. Priority is very, very important to make it primary and secondary gateways. Okay, so in next session we will discuss about HSRP with the ARP protocol. Okay, just ARP is already discussed in last sessions, in previous our sessions. So I will explain one more time ARP, how ARP works here. Okay, right? So we will discuss that in the next session.